Let's say you've got a block of rock that you know has a fossil in it. How do we get this fossil out of the rock? If you've seen any of the preparation videos on my channel before, you'll have seen a couple of the methods that we could use. The first is mechanical. We could use something like a Dremel or an air scribe to chip away the matrix. You could also use powders to blast away the matrix in a method called air abrasion. Or, if the matrix is calcium rich and the fossil isn't, we could use an acid to dissolve the matrix and leave the fossil. But all of these methods will potentially damage the fossil, either during the preparation itself or afterwards, due to the fossil now being out of its matrix and exposed to the environment. So what is the alternative? We can do a virtual preparation. We can use CT scans, or more recently synchrotron scans, and using large quantities of X-ray energy, we can image the inside of rocks. There are other methods that use protons or even neutrons instead of X-rays to obtain similar images. These methods all allow us to look inside of the matrix to see what is inside without physically removing any of the matrix. This resulting stack of images that make up the scan volume can then be segmented. Segmentation is a process that is effectively very fancy coloring in. It allows us to color in an area of interest on each image within the stack and then lets the computer join these areas of interest across all of the images together to create a 3D volume. This allows us to create virtual 3D reconstructions of the fossil and allows us to potentially reveal material not visible on the surface. This segmentation or digital preparation can either be the end point, we can stop preparation at this point just using the virtual, or we can use it to help inform traditional mechanical preparation techniques. So for example, we might find that there's a fossil inside the matrix that we didn't know about, and we want to have to be careful in that area when we're preparing down to it. Digital or virtual preparation allows us to also further look inside our fossils in a way that wasn't possible previously. For example, if we want to extract information about the brain of an animal, if we wanted to do it traditionally, we'd have to cut our fossil in half, fill the brain case in with a silicon mold, and then extract that silicon mold to create our volume. But using a virtual method, we can do this without damaging the fossil. There's no cuts required, it's just CT scans or X-rays. So why don't we then do this for all of our fossils? Every preparation technique has a trade-off. Historically, cost was the big limiting factor for scanning. We might have spent hundreds or even thousands of pounds to scan fossils in the old days. But costs have come down a long way, and we're looking at about 40 to 50 pounds an hour to scan fossils at some of the facilities in the UK. But big fossils may still take many hours to scan, and even then you may not get great contrast between the matrix and the fossil, which makes this coloring in, the segmentation afterwards, very difficult. Some fossils have an iron-rich matrix, which tends to cause starburst patterns in the scans, and this obscures the fossils in the matrix even further. Additionally, segmentation is not a fast process. It can take many hours of work on generally high-powered computers that require specialist software. That being said, there's a rise of open source and free software like Slicer 3D, which means that segmentation too is getting cheaper and is now becoming available to the masses on even home computers. Ultimately, digital preparation is just another tool in the paleontologist's arsenal. It will not replace traditional preparation, but it allows us to supplement those methods in new ways, and it helps bring paleontology into a new, modern digital era.